My name's Mike, and we're talking about flAWS, and that is to do with AWS security. First, who am I? I'm a software engineer, CTO at a company called students.com, and we're based in WeWork Spinningfields. For anyone who happens to be based in WeWork, come say hi, we're on the second floor. I'm also a northerner and a skydiver, and you can follow me on Twitter at M1KE. Now, cloud has become the most on-trend way to leak all of your data to a bunch of people who you've never met before. And if you want to avoid yourselves getting in the papers, or these days getting hauled up in front of whoever's responsible for implementing GDPR, who knows what will change with that after Brexit, but maybe it'll stay around, maybe all the cookie notices will go away. You need to make sure that your security of your cloud infrastructure is under control. Now, people here might not be the ones responsible for that. I don't know the size of companies you work for. Some of you work for big teams who have security people, and you can kind of just ignore all of it. Well, ultimately, you can't. The cloud has brought development and infrastructure and security closer together than ever before. Most people who have some level of putting applications in the cloud, whether that's front-enders writing JavaScript, whether that's project managers coordinating tasks and deciding on deadlines, or whether you are actually doing infrastructure and security, you're going to have some part of your work which is going to touch cloud security. What I'm talking about today is based on a resource called flAWS.cloud. This is a simple training platform, totally free, that was made by Scott Piper of Summit Root in the US to train you in basic AWS security. Some of it has gone a little out of date because it was made about 5 or 6 years ago, but a lot of it is still very relevant, and almost embarrassingly so. We're still seeing the same mistakes being made in cloud security now as we were 5 years ago, and as probably we will be in another 5 years' time. So this is stuff that's important for everyone to learn, and that's why I'm talking to you about it today. We're going to break the talk into 6 sections, and each section roughly corresponds to a level of flAWS.cloud. So what I'd really encourage you to do is make a note of that. I will put it up on the screen again at the end. And then once you've gone home, go try it for yourself. Anyone who knows how to use a website and a command line can take advantage of using these tools. There are hints as well, and I'll be putting my slides online. So if you don't feel you want to cheat your way through flAWS.cloud, look at my slides. They'll teach you what you need to know, and then go and hack the site yourself. So, web hosting and public permissions. S3 has become known for its ability to host static websites. And for people, especially in front-end positions, that's a really great thing. You can host a whole website in S3, and then you can have that make some sort of calls to a server hosted somewhere totally different, and you don't need to think about your server architecture. You simply deploy, whether it's React, whether it's Vue, whether it's something else, you deploy your files, and they're hosted in S3, and you have a website accessible. For those who haven't encountered S3, S3 stands for Simple Storage Service, part of Amazon's long chain of acronyms that they've since developed. And S3 has a bucket, which is a geographic location of files. So buckets are in a specific region, and they have a unique name. And those names are globally unique, and that's important for the website hosting. And then we have objects. An object is basically a file in S3. So Amazon basically like to change all the terminology so they can sell their certification courses better. So you have to learn that terminology first, but essentially buckets are directories and objects are files. And now web hosting. You can host a static website very easily on S3. And this is the reason they must have a globally unique name. Every bucket is in a region. So if I can point to the regions there, you've got US East 1, which was our original region, US West 2, which is London, and various other regions. For websites, a bucket name must match a web address. You can also access every S3 website at a different address. So your bucket name, .s3 website -region, such as US2, .amazonaws.com. This is quite useful for researching a target. If you know you want to hack a certain website, and maybe you find that website is hosted on AWS, and maybe you suspect it's hosted on AWS, you can find out if that suspicion is true. By running dig on the domain name, you can find out what the IP address is of that website. Following which, you can do an NS lookup on the IP to find that that's registered to S3 website US West 2. You now know that this person has got a bucket named flAWS.cloud, and they're in the US West 2 region of AWS. And following which, we want to see what's in the bucket. Well, we can see what's in their bucket if they've made the following mistakes. Everything on AWS is controlled by policies. Policies are these JSON documents that look, again, very hard to read and hopefully sell AWS certification courses. They define what you can do with a certain resource in AWS. This basically says anything in AWS can access get object on your bucket name. And this is a standard thing that gets added automatically by AWS to your bucket when you set up a website. Unfortunately, users don't necessarily know if that's worked because sometimes there's maybe a slight delay on the policy having effect or a delay on your DNS propagating. And they go, oh, it's not working. Well, they look around the control panel for other things. Oh, wait, list objects wasn't set on this page, which is right next to where the bucket policy is. Cool, I'll just tick it. Well, now we can exploit this using AWS's CLI tool. Everything in AWS is controlled by an API. The whole system is an API. It's brilliant for automation and programming. To normally use the API, you would enter an access key and a secret access key in order to log it as your account and do things that your account has access to. But it turns out you can also use the AWS CLI tool anonymously because AWS knows that some things can just be run without a user. As far as they're considered, if someone hasn't requested their items be protected against users and just made public, why should you have to be using AWS to access the API? So you can run this command. Fairly simply, this is an AWS program accessing the S3 endpoint, running ls, a familiar command to anyone on Unix, listing the directory contents of this protocol S3 and this bucket name. And then we can add this no sign request, which basically says, I'm anonymous, don't sign my request with anyone's keys. And then you put in the region you want to access, because generally you will be accessing it in your own local region, which probably for people here isn't US East or US West 2. And say we've hidden some sort of secret file containing something important in our website, but obviously it's a random file name, it's a really long string, no one's ever going to guess it. Unfortunately, that's now not true, because having run this command with this ACL with list objects present, someone can now see everything in our bucket. And anything you thought was secret is now no longer secret. That might seem very minor. We're going to talk in a little bit about some bigger risks for that. But ACLs present other problems because naming things is hard. People may have heard the quote that naming things is one of the hard problems of computer science. So the bucket isn't just public, right? You've found someone's website, you think, oh great, it's all public. It's not, you've done that research, it's not public. Well, what else can you do? Luckily, there are other mistakes people might make. The canned ACL. AWS has helpfully written a lot of pre-designed permissions for people who don't want to learn their syntax and their permissioning system. So you can just apply a pre-written permission to your bucket. And the idea of this is people just choose the most appropriate permission system for them, and they go with it, and they don't have to think about it again. Unfortunately, in security, people not having to think about things tends to reveal there's a problem somewhere. Let's look at one specific permission. This is the authenticated read naming, which says owner gets full control and authenticated users get read access. You may apply this to an S3 bucket because what you want is that you are the owner, your developer account is the owner, and you have some files in it, but you want your team to access it, and all your team are authenticated AWS users. So you give them this access, and your team can all access the files, so that's great. What you don't realize is authenticated users is every AWS account that exists. So if you give this permission, anyone with any AWS account anywhere can give themselves permission to read your files. It's a more bizarre twist of naming things, which I think really should be better handled. So how can we exploit that? Well, we now have to create our own AWS account. So if you don't use AWS here, this is where you have to set up an account. You will need to put a credit card in. It won't be charged for any of the things you'll do during part of this workshop. So having an AWS account is essential. You're going to generate an access key. If you then decide to take this account from being a little test account that you use for this talk and turn it into like a production account for a big company, add some more security, because I'm not teaching you how to set up a really secure AWS account here. Use good sense. So now you can set up a CLI profile. You run this AWS configure profile, and we'll call it Manc Web, because that's where we are. You enter an access key, a secret key, default region. So we're going to do US West 2, because that's what we're looking at. And what kind of output you want. JSON sort of makes sense. You run the same command, list this bucket, and put your profile in, Manc Web, and suddenly you'll find that once again, despite the fact you couldn't list this with no signing request, they have added an authenticated user's canned ACL, and you get to read everything in the file. So once again, ways people can inadvertently give you access to everything in an S3 bucket. Now obviously this is for static web hosting, but these files that people are sharing in this method could be anything. These could be database backups. These could be important user personal details. A company once just sent me a CSV of some users on their system and hadn't noticed that if they scrolled a little bit to one side, it had all the users' credit card numbers. So people make silly mistakes and they think they're sharing a simple CSV of a few emails and names and they're sharing people's credit card numbers. So don't assume this kind of stuff won't be happening at your business if your business is using S3 to store and especially to share files. You can fix this with policies. It's always good to prevent people making mistakes in the first place. you can make a policy which actually says you will only accept an object being uploaded to this bucket if the policy is public read. And that makes it very clear to anyone who's typing public read that this is a public bucket. So don't put your customer's personal data in. Similarly, you can do private read. So you can prevent someone ever making anything in this bucket public. Not great for website hosting, but really good for securing personal data. Here's a fun one. Exposing credentials on Git. Are the risks of having my website bucket public? So you might be thinking, oh, well, you know what, I reckon we probably have ticked that thing, but it's fine, it's just our website. Like, someone can just read our HTML, we're making that public on the website anyway, we don't have anything secret in there. Are you sure? The S3 sync command is a really good way to deploy your websites. You say sync my website and S3 mywebsite.com, and it uploads everything in this directory to this directory. Everything in this case includes your .dot files. And for anyone who knows how Git works, that includes .git and everything in there. So we can do the same thing we did earlier. We can list someone's bucket with a no-sign request because they've made it public as a website. And this time we see a prefix which says .git. We now know that someone has uploaded their Git repository, generally in full, all the branches they had on their machine at the time, to their website. Now again, maybe it's fine, maybe it's just their website content, but let's have a look inside that Git repo. So we sync the files back down to our system, and we run git log. So we get a list of their commits. And it seems like their second commit is an odd one. They've committed something they shouldn't have and reverted it, which obviously means it's completely gone forever, safely deleted, right? Well, that's not how Git works. Let's check out the first commit. Oh dear. Access keys.txt. And now we have access to your AWS account. Let's just hope that this is an account with very limited permissions and not your admin account, right? So now we can set this up in our own profile, because obviously we're ethical hackers. We want to make sure we know what we're exploring, so we add their keys to our account. And then we're going to play around with their account and try and do something that's non-destructive in order to find out what we have access to before we can disclose it to someone and hopefully get paid a bug bounty. You might be thinking, well, what just happened? Why was that an issue? There's a principle in security called defense in depth. This exploit we just did, where we found someone's Git repo, then found their keys, then used their keys, required multiple mistakes to be made. Firstly, it required a website to be set up incorrectly. It required someone to synchronize their .git directory with a website that was set up incorrectly. Then it required that Git directory to have keys committed to it. Then it required them to be committing the whole Git branch. Finally, it required them to have not noticed this and silently hidden their mistake and not removed those keys. So with most development we do, a single bug, a single issue that we put into our code will cause maybe a single issue to an end user. You know, we might be 95% of our systems work. The 5% that doesn't, we say that's edge cases. Oh, this will never happen. Or this happens to one user a week or something very minor. Security generates the opposite. A single mistake somewhere in your entire stack can compromise your entire system. And at that point, depending on what your company does, it goes from being quite embarrassing to game over. So you have to make sure that you are defending every level of your system and not assuming that the protections you have at the top levels, like, oh, look, this is a secret key, are compromised by removing protections at the bottom levels. Like, ooh, we just put it in a Git repo. I don't want to tell anyone because I'm embarrassed about that fact. This has happened to my company. We had an intern start with us. We decided to get him to do some testing on a database. And then I got a phone call on a Saturday going, hey, I wanted to show some people what work I've been doing. And I uploaded the code to GitHub, and it had your live database credentials hard-coded into it. So these mistakes can happen, and it's important that people fess up. So if you ever get a key leaked in this way, roll it, change it straight away. And even if there's no risk, rotate your keys regularly anyway. You never know where they're going to have ended up. Shortcuts. It's great in the cloud that there's so many different ways you can do things. Unfortunately, that also means there's so many different ways you can make horrible mistakes. This is an interesting one where someone can clone your entire hard drive and find whatever's on it. So let's go back to good old servers. S3 is weird, it's scary, it calls things buckets. We're not in for that, although we are on the beach, so maybe it makes sense. Thank you. And we're going back to EC2. EC2 is Elastic Compute Cloud, which again is Amazon's love of acronyms, their servers, their virtual servers, that's what they are. And they have snapshots. This is common to other cloud platforms as well, the idea of having a snapshot. And in this case, they're stored in S3. Amazon's documents will tell you they're stored in S3, but they're not really accessible in S3, so that's not really a vector to attack them. And EBS, Elastic Block Store, this is quite cool. Amazon allow you to basically dynamically move hard drives between instances at any time. And you can dynamically resize them, you can change the amount of operations they can perform, you can change the disk type from an SSD to a magnetic disk or to really high-powered SSDs. They're very cool. And so you can do a lot of stuff with disks on AWS, is basically what I'm trying to say. We've set up our servers in the wrong account. We needed them in our dev one because we're just doing some experimentation at the moment. But you can share snapshots, so that's great. We can take a snapshot of our server and share it somewhere. How do we do that? Okay, AWS have a guide on it. Let's read the guide. Okay, open the console, choose some snapshots, select it, make the snapshot public or share it with... make the snapshot public. Okay, cool, we're good. Let's do this. We're going to make the snapshot public. That seems the easiest way to share it. I didn't read any further down the page. And so you can list a public snapshot, but there are a lot of them. I tried to do it yesterday, and I thought my terminal had crashed until eventually it just output the most JSON I've ever seen in the world, and then crashed. So it's not really very helpful. But to get some specific target snapshots, so say, let's put an example out there. You really hate your old company, and you want to hack them. So you need to find their account ID. Now, AWS kind of say that account IDs are private. And so you could do this. So if you know the account ID of a particular company, you want to find all their snapshots, then you can run this command with their owner ID in the place of XXX, and you get all their snapshots. But again, their account IDs are private. Maybe you weren't on the infrastructure team of your old company, so you don't know their account ID, right? Well, luckily, people are really good at keeping things private. This was a quick search I did on GitHub last night. So just for US East 1, 7,149 available ARNs. The ARN contains the account ID straight after this colon. So 7,149 available account IDs that I could harvest just on GitHub from a quick search last night. Account IDs are not private. Do not rely on them for your security. So once we found the ID online or from some keys we found earlier, we can do this. And we can find that you have a snapshot. And here's the ID of your snapshot, and we can find out that your snapshot's not encrypted. Doesn't seem good. But what does not encrypted mean? Well, EC2 can encrypt data at rest. This means that when the hard disk is not active and connected to an instance, or when you store it in a snapshot, it is encrypted. It's encrypted with a key that Amazon controls. Amazon's key management service is so good that even you as the user don't get the private keys. You can give different systems in AWS permission to access the private keys, but you don't ever get to see them. And not getting to see them is great because you can't accidentally leak them somewhere. And the best thing about this is that even if you publicize a snapshot that's encrypted, if someone doesn't also have access to the encryption key, and again, defense in depth, you'd have to be very silly to give someone access to the encryption key as well as your snapshot at the same time, they can't do anything with it. Well, in our case, the snapshot wasn't encrypted. So we can very easily exploit this. You can create a new volume with that snapshot ID. So you basically say, I want a hard disk that's a copy of this snapshot. Boom, now I have a hard disk. You create yourself a server in your account, you sign into it with your SSH key, and then once you're signed in, you mount that volume just like you would mount any other hard disk on a Linux Unix system. And now we can examine the disk, and let's, for example, say that this disk was used to set up a web server. Look, they've got a setup script for their web server. That's really good. That means they're using good practices to use automated scripts to control their servers rather than someone hacking it all in manually. But oh dear, their HT password file is in there. And their password is in that, and now we can find their password and we can access anything on that server. So if that server was some sort of hidden admin control panel that has full access to the company's database, once again, game over. So at this point you might be getting quite scared, maybe thinking that you're going to leave the cloud, or maybe stop being a developer entirely and just go and live on a beach somewhere. I'm going to keep mentioning it. And now we learn that you can expose all your credentials via a proxy running on any of your servers. Okay, there's no more surprises. Well, enter the EC2 metadata service. Every EC2 instance has a metadata server. It appears like a server that's running separately nearby. I strongly suspect there's something interesting going on in AWS's virtualization system to make this happen. And it has this address, 169.254.169.254. This has become so common that other cloud platforms are now using the same IP address to expose different metadata services to their own servers, which is great because it now means that someone writing a scraping tool for this IP address has even more reason to write it and make it really good. And this allows people to access an IAM role. Now you might wonder, like, you've got a Linux system running here, or a Windows system maybe. Why not have a piece of software running on the server that secures its credentials, that gives you access? But the problem is that then requires lots of custom APIs, lots of custom things that talk to a daemon process running some on the server. They have to open a socket or all sorts of weird things. Whereas making HTTP requests, that's pretty much built into every library, every platform, every program you can think of. So AWS can make their SDKs work across every platform they want and every platform their users want without any effort by simply exposing a HTTP interface. It's not got SSL because obviously there'd be no way internally of rolling things like certificates and expiry and handling signing. So it's just HTTP. So this gives info about the machine and the network, image used, and also information about its IAM role. Wait, I missed the last bit. So actually, I'm just going to give up on all this, and we're going to set up a proxy because I want to get some firewall restrictions. I've already heard one person today said that their company blocked Google Docs. That would suck if my company did it. So I would do this route, right? Let's set up a proxy on our internal server, and we'll just bust straight through that thing and go to Google Docs because we want to use it, right? It's good for slides. That's what these are on. So great. But now other people have remote access into your system. We've set up a proxy, and I can then proxy this address. Now, obviously, from externally, I can't access this address. If I try and access this address on my machine, it says it's not on the local network. If I fire this at your proxy, your machine sends a request to this IP, and because your machine is on AWS EC2, your machine has access to this server. You get a weird list of dates to start with. These are API versions. So AWS kind of maintain different API versions. You can generally just go into latest if you want to explore this. And definitely do explore this, like not necessarily via a proxy, but if you're running servers on EC2, SSH into one and just like access this HTTP endpoint and see what's in it. It's quite interesting. And we have a big list of things we can find information about. We can find host names, network, metrics, loads of stuff. We're interested in the IAM, which is Identity and Access Management. And we're going to go in there and we're going to go into the wonderfully titled Security Credentials folder. And this will just be the name of whatever user role the server is running on. So I've just called it Mike. And when we open this, there we go. We have an access key ID, we have a secret access key, and this really long string that's a token. And just like before, we can take this access key and the secret access key, and we can input that into our own profile. We've got one slight difference, which is that servers use something called roles. I've mentioned them a few times before. You might be wondering what I'm talking about. So a role is a way that an entity, so say a server or some other service on AWS, or even one of your developers, can gain temporary access to AWS permissions. The great thing about roles is you don't give user Bob access to download your database. You give user Bob access to temporarily assume a role that lets Bob download your database. The advantage of this is things like the role will be assumed for, say, half an hour, and then no longer assumed. So if Bob wanders home and someone steals the laptop on the way, Bob's credentials don't get your database because the role was given up a long time ago. Similarly, if someone intercepts your keys in transit, they have a very limited window to use them. You can set roles to be accessible from a minimum of 15 minutes. So a 15-minute role, if someone steals your keys, they've got to be very fast to compromise your account enough to do any serious damage in that time. Again, it's not the be-all and end-all of security, but defense in depth means that limiting the time span of compromised credentials is really important. So if you want to exploit some credentials that you have happened to find in the way we've just done, then you can do exactly what we've done before, where you do AWS configure with the access key and ID, but then you have to create this extra file in AWS credentials and give it the name of your profile you're creating and put in that really long string as a session token. And at this point, the clock is ticking. That session token will only be valid for a short period of time. So whatever you want to do that's weird and malicious and fun, then you have to do it in that short period of time yourself. But obviously, if that session token has administrator access, you can very quickly spin yourself up a new admin user with infinite session token length. And again, it's game over. How can we mitigate this? Don't run proxies on servers on EC2 or really anything you control. Proxies are weird and dangerous. If you really need to use a whitelist, so just say, okay, this is going to access docs.google.com, and that's it. or put some sort of authentication in front of your proxy. And you can also specifically block the metadata IP. So for example, we now have a WAF rule in front of our system that just any request coming in with that IP on the end, probably someone trying to hack us. Even if it's not going to do anything, I don't want that request getting through. I want them to just get blocked at the firewall. And I want to know about it because it means someone somewhere is trying something fun with us. If you want the nuclear option, you can block all local applications from accessing that metadata service, but that will break any tools on your server that use other AWS interfaces. Probably not what you want to do if you're on AWS. So finally, you're probably panicking at this point. You're probably, all deciding that actually, even, going on a beach somewhere is bad. You're going to go in a cave and just hide and maybe cry. Or we could get someone to come and fix all the things for us. This isn't me pitching my services, don't worry. Okay, someone is going to come and sort it out for me. Right, we're going to get a security auditor in to check everything out and make sure everything is good. Right, and they're going to come in and fix it all and it's going to be fine. And in order to do this, we have to do something first, right? They're going to come in, they need some access to see our account. And by this point, we've wised up, we're not giving them admin access. No way. AWS have canned policies, so as well as the canned ACL in S3, you can literally give someone a canned policy that gives them like a pre-designed set of access to your account that they can use for some sort of use that AWS have determined. Often though, they are overly permissioned. They decide they don't want to break anyone's weird use cases, so they just kind of give you access to a bit more than you need. And if you remember what I said earlier about defense in depth, that should be ringing alarm bells. So security audit is a canned policy which lets you examine resources in an account, which sounds like the thing that we should give to our security auditor. So what's wrong? Well, AWS have a few ways of detecting if maybe you have been subject of some sort of malicious hacking activity. CloudTrail stores every activity, every API access, which is everything, on your account. And it saves whether the command failed or succeeded. So it says, at this point, someone downloaded a file from S3, the command succeeded. At this point, someone tried to download your database backups from S3, the command failed. And then you might want to go, well, why did that happen? Why did that command fail? Was it someone from a weird IP address? If I've suddenly got a lot of Russian IPs with commands failing, am I under some form of attack? Now that can be quite hard to monitor. CloudTrail can have literally millions of events per day. And so AWS designed a tool called Guard Duty. And this is automated threat detection, which you will definitely want to turn on the AWS account. It costs a little bit of money, but you're talking sort of dollars on a small account, maybe hundreds of dollars on a big account. But Guard Duty analyzes your CloudTrail data in real time. It's about 4 hours late, actually. But in real time. And then sends you messages via CloudWatch and SNS, Simple Notification Service. What did I say about acronyms? And sends you notifications to say, hey, we just spotted this thing happening, not sure if you want to check it out. And sometimes it does things like, oh, we just saw someone ping an IP that's used for crypto miners. Is your server meant to be doing that? Or they'll say something like, hey, someone just logged in from a train. We don't usually see people on your account log in from trains. Is this you? Which for me it usually is, but for other people it might not be. And so therefore you can catch anyone doing weird things. So someone gets a key on your account, by default they don't know what that key can do. Right? So they have a key, but if they start going, all right, I want to spin up a server, and then you get an access denied, somewhere that's logged in their CloudTrail, Guard Duty's picking it up, they know their key's been compromised, they're going to roll the key. Okay? So having these things on is really good because you can spot people who might have access to part of your account but not all of it. Well, unfortunately, our security audit role has access to view the details of all policies on an account. And that means that when you compromise a set of keys that have the security audit role, you now can find out the things that you, as a user who's compromised this account, can do. And suddenly you're able to know exactly which commands will set off the alarms and which won't. So in general, letting users know what they can do on your account, so this might be something you do with your dev team in general. You might say to your dev team, okay, we want our dev team to know what commands they can carry out on AWS. So even without write access, users who can read iron policies can pose a risk. So be careful with that. And the name of managing this is least privilege. It's so tempting when you're setting up, especially if you're prototyping or just getting into cloud, just give all your users the biggest privilege you can to avoid them constantly saying, hey, I don't have access to this, I don't have access to this. Try and avoid that temptation unless you really are sure that you're never going to use this thing in production. And I don't know many people who start prototyping who don't eventually accidentally end up with their prototype running a production website for 5 years. Give the user the roles they need, right? It might be one time, one day, a few days of a user saying, oh, I need this one as well. Oh, and now I need this one too. But very quickly you'll get that sorted and you'll have a really nice policy document explaining what your users can do. And now your users aren't going to suddenly find their credentials are compromised and they're doing some weird stuff down the line, like starting up massive servers to do huge crypto mining on your account. AWS have servers that can cost about $30 an hour to run. So even a very short window of someone having access to spin up servers in your account can be pretty damaging financially to you. And there's no way of limiting access to those if someone has admin access to your account. So when you use a CAN policy as well, if an AWS support person or an article online, especially an article not written by AWS online, just says, hey, just use this policy, read it through. If I wanted to compromise lots of people right now, I would write a load of articles explaining how to use S3 or DynamoDB with policies that were just slightly broken. And very soon loads of people would be using those policies, and then I would go and compromise their accounts. I haven't done that yet. So you need to do it for yourself to really understand it, and that's why flAWS.cloud exists. The guy who wrote this is brilliant. He let me use his examples in talks, and yeah, I'm not getting anything for doing this. But yeah, go check it out, flAWS.cloud. It'll walk you through stuff. There's loads of hints. I mean, basically, if you keep clicking, give me another hint, eventually it just tells you how to do it. But use what I've done in the slides to try and learn the system, because then you'll actually know what you're doing rather than just clicking through hints. But it's really useful if you want to learn how to hack AWS, or more particularly for most of you, probably how to protect your own AWS accounts. As a summary, role credentials regularly, right? If you have access keys, if you have passwords, I know it's annoying when everyone makes you change your password, but these things are important and things can get leaked and people can be using your account for a long time afterwards. So role credentials. Least privilege, just don't give people access they don't need. S3 has a new block public access feature that got rolled out sort of middle of last year. If you put it on a bucket that already exists and is serving traffic, you might break things. But any new bucket you make, just block public access by default. And then if you need to, you can knowingly turn it off. And finally, again, we're generally an audience of developers probably here. Insecurity is a bug. It's not the responsibility of someone else. It's the responsibility of the development team and the rest of the company to fix those things. So go fix them. Thank you very much. As I say, you can find me on Twitter at M1KE. If you want to find more information about AWS or some very cool, smart people, I'm not including myself in that, go to OG AWS on Slack. Thanks again to Scott Piper. And does anyone have any questions?